Well, my dear students, today video class we are going to discuss the important topic of a plus 2. That's the name of the topic is ray optics. In this ray optics, we are going to talk something, the characteristic of light and other things. Okay, we know that light travels in a straight line in a given medium. Everyone knows that light travels straight line in given medium. That means this is the sources of light. The light coming from the source moving through in one direction. This represents the path of the light. Which represents the path of the light. The path of the light represented in straight line is called a ray. That's a ray. So this is the source of light. Is moving the particular direction, that is in a straight line. So this is a path of light. The path of the light is called a ray. Ray. Such a collection of rays. These are called beam. This is a ray of light. The collection of rays are called beam of light. Okay, we know that light travels in a straight line in a given medium. When does it change the direction? Does it change direction? Yes, it changes the direction if light coming from the source moving a particular direction. So the arrow here denotes the direction of the path of the light. That is a ray of light moving. If any obstacle is placed in a path of the light, any obstacle, immediately it changes the direction. Even the direction is also a straight line. But light travels in a straight line in a given medium, but it changes the direction if the light incident on any one of the obstacle. After incident, it changes the direction. So the ray of light does not give any information about the intensity of light and as well as the color. It does not give any information about intensity of this ray of light, does not give any information regarding their intensity and as well as some other characters like colors and other things. But it has some characteristic. By using the ray of light, the collection of beam, now we are going to discuss something about the characteristic. One of these characteristics are reflection, refraction, dispersion, scattering. Now these things we are going to discuss by using the ray of light. So the ray of light obey reflection, refraction, dispersion, scattering. In this class we will discuss only the part of reflection. Okay, what is a reflection? reflection. Let us consider any obstacle like a mirror. A ray of light coming from the source incident on the one of the obstacle reflected back. Almost 90 to 90% of the light can be reflected when the surface is polished. When the surface is, if the surface is completely polished, a ray of light incident on the surface is 90 to 90% can be reflected. So the reflection takes place when the ray of light incident on. So let's consider the plane mirror. A plane mirror is reflect at least 90 to 90% of the light coming from the source. Okay, let us consider this is the plane mirror. It is a polished one side. Polished one side. It is a plane mirror. It is a XY. XY is a plane mirror. A light coming from the source. Incident, certain angle with respect to XY. So this arrow, it denotes direction of the ray coming from the source. Incident of the point. Suppose O. This is the A. AO, what is called AO? AO is called the incident ray. AO is called incident ray. After incident at a point O on XY surface, reflected back. Reflected back. OB. So OB is called reflected ray. AO is called incident ray. OB is called reflected ray. OB is called reflected ray. So, if the normal drawn to the surface, this is called normal. Normal drawn to the surface at a point of incident. Normal drawn to the reflecting surface at a point of incidence. At a point of incident. But it makes an angle something. So, the incident ray making angle with respect to the incident ray. Reflected ray making angle something with the incident normal. So, this is called normal. N represents normal. Normal drawn to the surface at a point of reflection of incident ray. It makes an angle something with the AO and also something with the AB. What is this? This is represented by I. I is called angle of incidence. Angle of incidence. That is angle between incident ray and normal. That is AON. Angle AON. It is angle of incidence. Similarly, BO. Making certain angle with normal. This is represented by R. R is called angle of reflection. R is called angle of reflection. So the angle made AO with normal, BO with normal. So it is angle of incidence. I represents angle of incidence. R represents angle of reflection. That is angle BON. So angle BON, angle of reflection. Angle AON, angle of incidence. Okay. From that, we can make the law of reflection. What are the laws of reflection? The laws of reflection. Laws of reflection. If angle between incident and reflection, angle between incident and reflection are equal. If AO make an angle I with respect to normal, the same angle BO make an angle with respect to normal. The angle of incident which is equal to angle of reflection. If ray of light incident at the point O, suppose 30 degree, the angle of reflection is also 30 degree. If angle AO, incident ray making certain angle with respect to normal is a 45 degree, the BO making angle with respect to N is also 45 degree. Angle of incident which is equal to angle of reflection. So, angle of incidence which is equal to angle of reflection. Angle between incident is equal to angle between incident and normal which is equal to angle between reflection and normal. It is one of the law. Second law. Incident ray, reflected ray, normal drawn to the surface at a point of incident, all lie in same plane. All lie in same plane. Incident ray, reflected ray, normal drawn to the surface at a point of incident on the surface, all lie in the same point. Same point. It is another law. So, if they ask what are laws of reflection, angle of incident must equal to angle of reflection. Incident ray, normal ray, incident ray, reflected ray, normal to the surface, normal drawn to the surface at a point of incident, all lie in the same point. So, these are called laws of reflection. So, incident, reflected ray, normal drawn to the surface at a point of contact, point of incident ray, all lie in same plane. Laws of reflection. Angle of incident which is equal to angle of reflection. Incident ray, reflected ray, normal drawn to the surface at a point of incident, all lie in the same plane. This law of reflection. If suppose this is the plane mirror, X, Y. X, Y is the plane mirror. A ray of light coming from the source incident at a point O, that is AO. AO is called incident ray. Once again, after incident of the plane mirror, reflected back to the same medium. So B. So this is reflected. A reflected ray. If XY the plane mirror, after incident on the plane mirror, reflected ray. If the plane mirror is not there, the ray of light has to be travelled like this. Actually, this is the original path of the light. It is the original path of light. We know that light travels in a straight line. Light travels in a straight line. Because of this obstacle is a place on a path of the light, reflected back. The path changed, the direction changed. Direction change. So, if the XY is not there, it would have travelled in a straight line. So, AO incident beam, OB reflected beam, actually it would have travelled on the direction OC. The direction OC. What is this? AO incident beam, OB reflected beam, but it would have travelled in this path at a point in the direction OC. If the XY is not there, XY is not there. This much changes occur when the path of the plane mirror is a plane. The plane mirror is a place in the path of the light. This much change. So this is called angle of deviation, D. Angle of deviation. D is called angle of deviation. If the path, if the XY plane is not a place, not place, travel in a straight line. Because of the XY is a place, it change in the path from OC to OB. So OC to OB, the change is a D. D represents angle of deviation. Angle of deviation. If normal drawn to the surface at the point of incident, we know that it is an angle of incidence, it is an angle of reflection. Angle of reflection. Okay. AO making angle with OX on XY plane. On XY plane. AO making angle with OX on the plane XY. That is AOX is equal to alpha. AON, it is angle of incidence. What is this? This is also some angle made with the XY plane on OX. AY with the XY making angle on the surface a plane mirror XY. So this is a glancing angle. It's called a glancing angle. If a ray of light incident at the point of incident on the surface is 30 degree, it is a 30 degree, the glancing angle, so 90 minus 30, so this is a 60 degree. The glancing angle is 60 degree. So this is incident angle. Angle of incident is a 30 degree, glancing angle is a 60 degree. It is 90 minus, so the normal down to the surface XY is exactly 90. 90 minus 30, it is a 60 degree. This is alpha, we know that. Angle of incident which is equal to angle of reflection. Angle of incident which is equal to angle of reflection. If AO making angle alpha with the XY plane on OX, it is a glancing angle. Why not? BON is also R. Angle of incident which is equal to angle of reflection. So this is also called glancing angle. If AOX making angle, the same angle is equal to BOY. Because angle of incident which is equal to angle of reflection. If angle of incident which is equal to angle of reflection, this AON which is equal to BON. Same time AOX which is equal to BOY. So AOX angle AOX is equal to angle BOY. If AON is equal to I, BON is equal to R. If I is equal to R, so AOX which is equal to BOY. This is also equal to BOY. If it is alpha, this is also equal to alpha. So this is also called glancing angle. If ray of light incident on the surface is 30 degree, the glancing angle 60 degree, here also 60 degree. Okay, now come to the point. What is a COY? COY. The angle COY. The angle COY which is equal to angle AOX. Angle COY is equal to angle AOX. If angle AOX is equal to alpha, AOX is equal to alpha, COY is also equal to alpha. So this is also alpha. This is also alpha. So this is a glancing angle. Alpha represents a glancing angle. But if the path in the path of the light XY in the plane where it's not a place, it would have traveled in a straight line on the path of OC. If the plane where is a place, it deviates OB instead of OC. How much deviated? D. Deviation. D is equal to this alpha, this alpha. So alpha plus alpha is equal to 2 alpha. Angle of deviation. Angle of deviation is always equal to twice the glancing angle. Any ray of light incident on the surface, they reflected back to the same area, but Angle of deviation is always equal to twice angle of glancing angle. Angle of deviation is equal to twice angle of glancing angle. If a glancing angle is 60, glancing angle is 60, deviation is 120. Deviation is 120. So glancing angle 60 degree. If glancing angle 60 degrees, 60 into 2, 60 into 2, 120 degree. So 120 degree is divided. So this is equal to, so actually this path, angle is 180 degree. Angle is 180. This is I, this is R. I which is equal to R. So 2I. Here I is equal to R. How much it changes? Deviation. Otherwise is equal to 190 minus 2I. So it is 2 alpha or D is equal to 180 minus 2I. 180 minus 2I. So a ray of light incident on the surface on a plane mirror, deviate always equal to twice angle of twice the glancing angle. Twice glancing angle. D is always equal to twice the glancing angle. If suppose same plane mirror XY, if a ray of light incident on the surface at a point O, it is A reflected back to the same medium. Suppose B, OB, AO incident beam, OB reflected beam. AO reflected beam with XY plane. If XY plane, we know that it is alpha, it would have traveled along this direction, OC. It is a OC. If it is alpha, what is this? It is a D. D is equal to 2 alpha. D is equal to 2 alpha. Angle of deviation. So AO incident ray, OB reflected. If XY is not a place on the path of light, would have traveled to OC direction. How much deviated? 2 alpha deviated. Alpha means angle of deviation. Alpha means angle of deviation. If suppose in the plane mirror, this is the plane mirror rotates certain angle theta, the same incident beam at a point O, the same light incident at a point O, even the plane mirrors rotate certain angle. Plane mirror rotate certain angle. So this D. So D is equal to 2 alpha. Now the plane mirror has been rotated certain angle. This is X prime, it is Y prime. Make an angle theta. Make an angle theta. AO incident beam, OB reflected beam for XY plane. For XY plane, this D is equal to 2 alpha. Is deviation is twice the angle of glancing angle. If the plane mirror is rotated certain angle theta with respect to XY, same ray of light incident at same point, the reflection has been changed to like this. It's a point P. For this ray of light incident, because the plane mirror, the reflection light. AO incident beam, OB reflected beam when the position XY. AO incident beam, OP is a reflected beam when the plane mirror rotate the angle theta. Plane mirror rotate theta. If plane mirror rotate theta, so totally this is glancing angle alpha plus theta. Alpha plus theta, we know that. Angle between incident and the surface, that is glancing angle. If it is a glancing angle, how much deviated? It is twice the glancing angle. So d prime is equal to 2 alpha plus theta. 2 alpha plus theta. We know that this is a glancing angle. The ray of light deviated is a 2 alpha. So 2 alpha is angle of, so deviation is equal to twice the glancing angle. If alpha is a glancing angle, this d, if the position of the xy, position of the plane mirror is xy, d is equal to 2 alpha. If position of the plane mirror changes in angle theta, now the glancing angle becomes alpha plus theta, so glancing angle. Now deviation, the new deviation, if the plane mirror changes x prime and y prime, the new angle of new deviation, angle of deviation 2 into alpha plus theta. We know that twice angle of or glancing angle. Alpha plus theta is a glancing angle when the position x prime and y prime. X prime and y prime. Say how much changes? Reflected beam. How much change? If AO incident and point O in the position xy, reflected beam OB. If the plane mirror changes the angle theta, how much angle change? How much angle change the reflected beam? The reflected beam has been rotated certain angle when the mirror is rotated. How to calculate? How to calculate this part? The angle BOP is equal to BOP which is equal to angle COP minus angle COB. Now we have to calculate BOP. How much angle? Reflected beam, how much angle of reflected beam will change when the plane will rotate at angle theta. So BOP is equal to COP minus C angle COB. So COP, that is D prime. This is the D. COP, this is a D prime. So COB, this is the D. So what is the D prime? D prime is 2 into alpha plus theta. 2 into alpha plus theta minus D, 2 alpha. So 2 alpha plus 2 theta minus 2 alpha. Alpha cancel. So 2 theta BOP. If the plane mirror has been rotated certain angle, refracted beam is also changed this certain angle. If the theta is a change, changes, how much angle refracted beam has been rotated? 2 theta angle rotated. If theta is a 10 degree, if xy is making angle 10 degree, refracted beam changes 20 degree. Reflected beam changes 20 degree. It is 2 theta. It is a 2 theta. If the same angle of incident, if already light is incident on the plane surface, reflected in OB, if the plane will rotate certain, like this, making certain angle with respect to xy, if making angle theta, the reflected beam has been rotated twice the angle of theta. If xy rotate 10 degree, BOB, reflected beam is a 20 degree. So BOB is equal to 2 theta. BOB is equal to 2 theta. Okay, let's move to now. Same plane mirror. Now I am keeping the position like this. XY. This is the plane mirror. If any object is placed in front of the plane mirror, light coming from the source, incident on the plane mirror, incident on the plane mirror, it is A, it is a O, A, O. After incident, what happened? Reflected back to the same medium. It is the B. This is the B. Normal drawn to the surface. This is the normal. We know that A-O-N-I, angle of incidence. A-O-N, angle of incidence. B-O-N, angle of reflection or angle of incidence. If a ray of light coming from the source, the object or place in front of the plane mirror, object placed in front of the plane mirror, incident on the point O, reflected back to the same media at same medium. So AO incident beam, OP reflected beam, normal drawn to the surface at a point of incidence, at a point of incident. Angle of incident which is equal to angle of reflection. Angle of incident which is equal to angle of reflection. Under ray coming from the source, incident normally on the plane mirror. One of the ray incident making certain angle with respect to the XY at point O. Another ray is incident on the plane mirror exactly normal. Exactly. What is the normal? Incident normally exactly 90 degrees with respect to surface. The angle between surface and ray of incident is exactly 90. Exactly 90. After incident on the surface, reflected beam has to be retraced on the original path. If any ray of light incident on the surface, any surface, this is a reflecting surface. A ray of light incident certain angle with respect to XY, it is ray has to be reflected. Ray of light incident certain angle with respect to XY, the ray has to be reflected. If the ray incident in the reflecting surface exactly incident normally, normal means the angle between incident bay and the surface exactly 90 degree is a normal. If light is incident normally, once again return back to the same medium, same retrace the original path, same path. There is no changes, no reflection at all. Reflection, incident angle between incident ray and reflect ray is 0. I and R is equal to 0. There is no angle. There is no angle. One of the ray incident at a point O reflected back. But another ray incident on the surface, retrace the original path. Suppose it put it, the name is a D. D. ADs, AO and AD both are incident rays. AO making angle I. Suppose maybe 10 degree, 20 degree, whatever may be. But AD is also making angle but 0. The angle between incident and normal is 0. Angle between incident and normal certain angle. Suppose ray incident along the normal, angle between incident ray and the normal is equal to 0. Angle of incident 0. If angle of incident 0, angle of reflection is also 0. Suppose a ray of light incident at a point D exactly perpendicular, retraced. Now the BO has to be extended. BO has to be extended. AO. AD is also extended. It is extended. BO, suppose for example, BO extended and AD is also extended. Extend. You put it is A prime. It is a prime. See this diagram. AD. AD is equal to DA prime. But the image has to be from A prime. Has to be A prime. So A is the object. This is reflected beam. But reflected beam has come from at the point O. It is coming inside the mirror. It's coming. It would have appeared to come from A prime. AO incident beam, AOB refracted beam, but the reflected beam would have come from A prime. Would have come from A prime. It is actually appeared to come from, but not actually coming from A prime. It's appeared to come from A prime. So AY is equal to, sorry, AD, not AY, AD. AD is equal to A prime D. The distance of object from the mirror is equal to distance of the image from the mirror. Distance of distance of the object, which is equal to distance of mirror. So the image distance, suppose if object is placed in front of 10 feet from the mirror, so image would appear 10 feet inside the mirror. So AD is equal to A prime D. Now we can explain with it geometrically. The angle AON. Angle AON. We know that AON. This is I. This I is equal to this. We know that it's an alternative. Angle DAO. AON. Angle AON is equal to DAO. Alternative angle. Similarly, BON. This angle is also equal to this one, or OA prime D. OA prime D. BON is equal to OA prime D. This is corresponding angle. If AON is equal to DAO, similarly BON, that is BON is equal to OA prime D. So these angle are equal, that's the alternative angle. These are the corresponding angle. In this triangle, it's a right angle triangle. In this triangle, ODA is equal to ODA prime. ODA is equal to OA prime D or ODA prime. So this is concurrent. Concurrent angle. AON which is equal to AON which is equal to DAO. BON is equal to OA prime D. If OD which is equal to OD prime and A. OA prime into D. These are the concurrent. Alternative angle, corresponding angle, concurrent angle. If these are equal, AD is equal to A prime D. Image distance which is equal to object distance. Image distance which is equal to object distance. So how much distance I place in front of the plane mirror, the same distance can be appear the image inside the mirror. It is one of the characteristic of the image formed by the plane mirror. What are the characteristic? What are the characteristic image formed by the plane mirror? Let's see the characteristic. Image formed by plane mirror. Image, the characteristic of the image formed by the plane mirror. One is size of the image. Size of the image which is equal to size of the object which is equal to size of the image. First one is image size. Size is equal to object size. If it is size of the image is 10 millimeter, so size of the object is 10 millimeter, the size of the image is also the 10 millimeter. The size of the image is equal to size of the object. And second one is the image is virtual. The image is a virtual. Image virtual, erect, straight. And laterally inverted. The image formed in the plane mirror, it is virtual image, erect and laterally inverted. Laterally inverted. Laterally inverted. And distance of object or image from mirror is equal to distance of object from mirror. So the image distance always equal to object distance from the mirror. And the final one is very, very important. How many number of images can be formed when the two mirrors are placed at an angle with respect to one another? If the two mirror, for example, it is one of the plane mirror, another plane mirror, making certain angle. If one of the mirrors is placed in front of us, only one image can be seen. If the two plane mirrors are placed at an angle with respect to one another, if the object is placed here, object is placed between mirror, how many images can be seen? See, we can experience in the saloon shops. In a saloon shop, there are two images or number of images placed on the wall in opposite side. If you are entering the shop, you could see the number of images can be seen, not a single image. Number of images can be seen. If the two mirror placed parallel to one another, but there is no angle between the two mirror. If the angle makes, why the image is formed infinite numbers when the plane mirror, the two mirrors are kept parallel to one another? Because from this equation, number of image n could be calculated 360 by theta. 360 by theta. If 360 by theta, theta is the angle between the mirror. If here is one is mirror, here is another mirror, so place a parallel to one another, angle between two mirrors. Suppose it is one of the mirror, it is another mirror. Now you are standing between the mirror. How many images could be seen? The number of images could be seen. Why? The angle between A and B 0. The angle between A and B 0. Anything by 0 is equal to infinity. Anything by 0 is equal to infinity. Condition if the two mirrors are placed parallel to one another, theta is equal to 0. If two mirrors are placed at an angle with respect to one another, number of images could be calculated. N is equal to 360 by theta. But actually it's not exact value. 360 by theta, there is another condition. If image is placed between mirror, either symmetrical or non-symmetrical. Symmetrical or non-symmetrical. The image is placed exactly symmetrical. But in this two mirror, if object is placed on side of any one of the mirror is non-symmetrical. Non-symmetrical. Suppose 360 by theta is equal to even number. Even number. 360 n is equal to 360 by theta. So 360 by, suppose 90 degree. The two mirrors kept at an angle exactly 90 degree. Exactly 90 degree. Exactly 90 degree. So it is the number 4. N is equal to 4. Not 4 images. Not 4 images are seen. But actually the condition either symmetrical or non-symmetrical. Symmetrical, exactly distance between the two mirrors are equal. If any one of the object is nearer to one of the image, is not symmetrical. But here you take n minus 1. So 360 by theta minus 1. So 4 minus 1 is equal to 3 images. So number of images could be calculated when the two mirrors kept a certain angle with respect to one another. 360 by theta minus 1. The condition, if 360 by theta gets even number, 360 by theta is equal to even number. So answer would be 360 by theta minus 1 when symmetrical or non-symmetrical. Symmetrical or non-symmetrical. If suppose, if n is equal to 360 by theta, odd number, for example, 360 by theta, 360 by theta, 360 by 72, we can get 70, so we can get 5. 360 by 70 is equal to 5. 5. The 5 is an odd number. The 5 is an odd number. Suppose the object is exactly between the two mirrors in symmetrical. In symmetrical. Now use 360 minus 1. 360 minus 1 by 360 by theta minus 1. So 5 minus 1 is equal to 4. 5 minus 1 is equal to 4. If object is in very close to one of the mirror, non-symmetrical, where keep it is 360 by theta. So 360 by theta is equal to 5. That is 75. If it is a symmetrical, in either even number or odd number, you subtract 1. It is a non-symmetrical in the case of odd. If you divide the theta from the 360, you keep it as it is. So number of images can be calculated by using the formula 360 by theta. If 360 by theta is an even number, you subtract 1 from original value. 360 by theta minus 1 either symmetrical or non-symmetrical. If odd number comes, symmetrical minus 1, non-symmetrical as it is. Non-symmetrical as it is. So these are the characteristics of the image formed by the plane mirror. So far, we have seen some character of ray of light when incident on the plane mirror. So one of the character is the reflection we have seen today. So the next class we will see the next part.